Today we're learning about the area of regular polygons. To begin with, let's review a couple vocab words. The first one being a polygon. So a polygon is a plane shape with straight sides. So you could say a polygon, an example of a polygon could be a rectangle, a square, a rhombus, a quadrilateral, a kite. So anything that has straight sides, a hexagon, an octagon, and so on, anything with straight sides. Now, beyond that, we are specifically working with regular polygons. And it's important that you understand this term because a regular polygon is a polygon that is equiangular, meaning same angle measures all the way around, and equilateral, meaning that the same side length is on, or every side is the same side length. So if we look at my model right here, this inside of the circle is going to be called a regular polygon. And I'm going to erase this just because it's not part of my diagram, but in a regular polygon, every side is exactly the same. So you don't need to see those little tick marks that I just drew to indicate that it's congruent. All it has to say is, here's a regular polygon, and you can automatically assume that all sides are equal. Within a regular polygon, there's a radius. Now, a radius is the distance from the center of the circle to a vertex. So I highlighted my radius in purple. We have multiple radii around this figure. If I highlighted them all, I'm just going to highlight all of the lines that start in the center and go to the edge of the circle or a vertex. There's a little note right here. It says in a regular polygon, all radii are congruent, just like all of the sides are congruent. Next is the apothem. The apothem is a perpendicular distance from the center to a side. The apothem is not the radius, so be very careful not to mix those up. I highlighted the apothem in orange. You can see it starts in the center and it just goes to the side of the regular polygon. It does not continue to the circle. It stops right there. Now let's talk about what that circle is for a moment. I have this note off to the side. It says you can draw a circle around any regular polygon. So here is our regular polygon. I drew a circle around it. The center of the regular polygon is the center of the circle. And that's what allows us to identify the radii. That's what allows us to identify the center. So that circle is very helpful. It allows us to use not only regular polygon properties, but circle properties as well. So what we're working towards today is finding the area of a regular polygon. Quick reminder, anytime you see a regular polygon, no matter how many sides it has, all of your sides are equal. It does not have to say that, it just has to say it's a regular polygon. But by knowing all sides are equal, you only need one side length, to find the perimeter. So the area formula for a regular polygon is stated as the area is equal to 1/2 times the apothem times the perimeter. And you have to find the apothem and find the perimeter before you can calculate the area. If we move on to our first example, this one says calculate the area of each regular polygon. So before I even start to find the area, what I want to do is indicate the parts and pieces I know about this figure. Because it says it's a regular polygon, I know that every side is the same length. That means that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. This is a decagon. I have 10 sides at 8 inches. So the perimeter is equal to the number of sides multiplied by the length of the sides. And in this case, the number of sides is 10, and the length of each side is 8. Therefore, the perimeter is equal to 80 inches. Okay, so besides from identifying what the perimeter is, we also need to identify what the apothem is. So the apothem is the length from the center of the circle to a side of the regular polygon. This is called the apothem. So the length of my apothem is 12.3 inches. And I'm just writing these down as notes, so when I fill them into the area formula, I know exactly what I'm filling in. Now that I have my information, I have the perimeter, I have the apothem length, I can use the area formula, which states that the area is equal to 1/2 multiplied by the apothem length times the perimeter length. And the apothem length we already calculated or we already determined, and the perimeter we also determined. So when I substitute these values in, I have 1/2 times the apothem length of 12.3 times the perimeter of 80. And when I type this into my calculator, the area is equal to 492 square inches. That's the area of this figure. That is your final answer. Okay, next we have a new figure. This one is inscribed inside of a circle. Now the circle just allows us to use our properties. We don't really need to do much with the circle. So we still need to identify the perimeter and the apothem length in order to find the area. So I see that each side is 12, and I can count that I have 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. To find the perimeter, we're going to do the number of sides, which is 8, multiplied by the length of each side, which we know is 12. And when I calculate what the perimeter is, I can calculate that this perimeter is 96 inches. Next up, I need to identify what the apothem is. And in my model here, it's the point from the center to the side of the regular polygon. And this is already labeled for me. So I know that the length of the apothem, represented with a lowercase a, is 4 times the square root of 3 inches. Once I have this information, I can calculate the area. When I substitute these values into the formula, I'm going to calculate 1/2 times 4 multiplied by the square root of 3, and we're multiplying this by 96. When I type this into my calculator, I end up with 384 times the square root of 3 divided by 2. And I'm going to leave this in exact form. I'm not going to round this, so I am not going to get rid of my square root of 3, because if I get rid of the square root of 3, that means I'm going to be rounding. So I'm going to write my final answer for the area as 192 multiplied by the square root of 3, and this is square inches. That is my final answer. Okay, next up we're looking at a quick review of special right triangles, which we have actually already talked about this unit. I believe in lesson 2, we also briefly discussed the special right triangle formula. So I don't think I need to spend time in the video going over this. There's other videos you can find if you need to review special right triangles. But I will just remind you that there's 2 types. So there's a 45-45-90 and there's a 30-60-90. For a 45-45-90, you have one equation. Hypotenuse is leg times the square root of 2. And for 30-60-90, you have 2 equations. There's no specific order as to which ones you use first. It's specifically dependent on the problem. So now let's move down to the next example. And this one says using special right triangles to find area. So we're looking to find the area of this regular polygon. I forgot to put that in the directions, so I'm just going to label regular polygon. And it also tells us to leave our answer in simplest radical form. So you should not be rounding, you should be leaving a radical in your answer if necessary. So there's some key parts here, and there's other key parts that you need to calculate. So you might want to watch this and then come back and copy it down after I do this first example. So here we see that each side is 10. So we know that we have 6 sides. I can count the sides. All of the sides are 10. So we're good with that. We also see that the apothem is missing. We know that this triangle here is half of the base, so that's why you see 5 millimeters versus 10, because it is half of one side. This is the other side here to make 10. We also see that we have a 30, 60, 90 triangle. So I'm going to redraw this triangle off to the side. I'm going to make it a little bit bigger. I'm going to label what I know. So I know that I have a 30-degree angle right here. It's labeled. I know that I have a 90-degree angle in the bottom corner. Oops. Okay, so now that I redrew the triangle, I'm going to label, or I'm going to write out some directions for you to follow along with. So this is going to be the first step. Step 1. We're going to calculate the apothem. And calculating the apothem is requiring us to use a 30, 60, 90 triangle. I see that I have the short side labeled as 5 millimeters. So I am going to work off of that. I'm going to work off of the fact that the short side is 5 millimeters and I need the length of A, which is the long side. So the long leg in a 30, 60, 90 is equivalent to the short side times the square root of 3. Substitute in my values. A is equal to 5 times the square root of 3. And this is the length of my apothem. Okay, after we calculate the apothem length, so after we use our triangle that's within the figure and we calculate that, the second step is going to be to calculate the perimeter, which we should all know how to do fairly easy at this point. So calculating the perimeter is something we've already done, and we're looking at the number of sides, which in this case is a hexagon, so 6, times the length of each side, which is 10. If this is the equation, our perimeter is 60 millimeters. And step 3 is to calculate the area. So calculating the area requires us to use a formula of area equals 1/2 times the apothem length times the perimeter. And we already calculated what those two values are. So when I substitute them into the equation, we have 1/2 times 5 square root of 3 times 60. We're leaving this in radical form, so multiply your numerators together. We have 300, that's 5 times 60, times the square root of 3, divided by 2. And when we simplify this, the area is equal to 300 divided by 2, which is 150, times the square root of 3, and this is square millimeters. That is your final answer. Okay, for the last two parts of the note sheet, I want you to be working on these by yourself. Now, I am going to complete them so you can come back to the video and you can watch me go through them, but it's important that you work your way through these on your own. So if we read the top of the second page, it says sometimes the the radius, apothem, or angle measures will not be visible in the figure. In that case, you need to add them yourself. So I'm just going to get you started on this regular triangle, and then I'm going to ask that you finish the rest of this page and the on your own section by yourself. So remember that a regular figure, any regular figure, has a center. The center is going to create a radius to every vertex or every corner of the figure. We also know that all the sides are equal, so we know those three sides are the same. What we need to find is these central angles. Well, if we go back to the beginning in the definition of a regular polygon, it says all angles are the same. So if we have 1, 2, 3 angles right here, we know that the total would be 360 divided by 3 for 3 angles, which gives us our central angle measure of 120. That means all 3 angles are 120. Next, we would need to add in the apothem. And the apothem is always the length from the center to a side of the figure. Remember that the apothem creates a right angle at the bottom. And if this entire angle is 120, then that means half of this angle would be 60. And now you created yourself a 30, 60, 90 triangle. So I want you to continue labeling these figures and put in everything you know about them. There's 2 more figures to work on. And then you can come back to the video and you can watch me go through each figure and label everything that I find important about them. And then the last section is an on your own section, which I highly suggest trying by yourself. But again, you can see my answers here in the video.